Today, we're going to talk about normal distribution and we're going to talk about how we can find probability using our calculator. So the main idea here is that we can use our calculator to find probabilities instead of using the C-value table when we talk about normal distribution. So we have seen how we can use the percentage underneath the curve. We have talked about the C-value table. And today we're going to see how we can use the calculator to find probability when we're still talking about a normal distribution. So let's look at some examples now. So here we have here we have a normal distribution problem. Let's get familiar with it. So now let's see. It says the monthly utility bill in a city is normally distributed. Okay, so it says that it's normally distributed. So that means that we can use normal distribution. So now we keep reading. We see that the mean is 100. So let's write that down. We know that the mean is 100. And we also know that the standard deviation is 12. And it says a utility bill is randomly selected. Excellent. Now, we want to find the probability that the utility bill is less than 80%. So here, let's just not call it value, let's call it the point of interest. The point that we're interested on is 80. Because it says here, we want to find the probability that the utility bill is less than 80. And again, as long as you have those three values, you can use your calculator to find the normal distribution. So now let's see. In here, this is what we're going to be putting on our calculator when we want to find our normal distribution using the calculator. But before we do that, let's actually just plug in what we know here. We know here that the mean is 100. So that means that right here at the center, this is 100 because we know that the mean is always 100. And our point of interest, we want to know, our point of interest is 80. So let's just say that 80 should be a little bit to the left. So let's just say that it's right here. So let's just see. This is our point of interest. Now, the question that we try to answer is here. We want to find the probability that the utility is less. So because it's less, we want to find out the left side of this graph. So this is what we're interested on. We want to find out what's the probability on the left side of this graph. Now, in order to do that, we're going to use our calculator. And here, so you're going to turn on your calculator. And we're going to use something called the Normal Cdf. Now, where can you find the Normal Cdf? The Normal Cdf, you can find it here under second and distribution. So let's press second, distribution, and now you have it right here on the second part. So you're going to press Normal Cdf, enter. So now what we have here is we're going to press Normal Cdf, which is what we have. And we're going to plug in what we know from the problem. Now here, notice that the first thing that you want to plug in is the lower bound or the lowest point. So we want from 80 to the left. So what you can do, if it's the lower bound, I always put that to 1000. So the lower bound, let's put that into 1000, negative 1000. The upper bound, if we want this whole region, the upper bound is going to be 80. Our mean, well, we know that our mean is 100. And our standard deviation, we know that that's 12. So let's just plug this in the calculator. The lower bound is negative 1000. Then you press comma. Then we're going to put down our upper bound, which is 80. Then you press another comma. Then our mean, which is 100, comma 12. So this is it. So now it says that we have a probability of 0.04777, but we always want that in percentage. So we do that, multiply it by 100. So that means there's a for 77% of probability. Let's try another example now. Now, if we read our problem here, this is what we have. The time per workout an athlete uses on stair climber is normally distributed. That's great, normal distribution. So now here's a piece of information that we're interested on. We know that the mean is 20. So let's write that down. The mean is 20. And we also know that the standard deviation is 5. Excellent. So the standard deviation is 5. An athlete is randomly selected. Excellent. Now we want to find the probability that the athlete uses the stair climber for more than 22 minutes. So here the value that we're interested is 22. Hold on, I didn't think I value, I think I put, yeah, let's be consistent. It doesn't matter if you call it value, doesn't matter if you call it point, but let's just be consistent. So our point of interest is 22. Excellent. Once we have those 3 pieces of information, then we can use our calculator. Again, if we're talking about normal distribution, let's just have visual interpretation of it. So let's plug in our mean. We know that the mean is right here at the center. And this is going to tell us that we know that the mean was 20 on the problem. So we know that this is 20. We know that the point of interest is 22. So if this is 20, 22, I don't know, should be somewhere over here. And now let's just do our line. Now, what is it that we're interested on? We're interested on find the probability that the athlete uses the stair climber for more than 22 minutes. So if we're looking for something that is more, we're going to be looking at the right side now. So this is what we're interested in. So let's see. Let's put our calculator here to the side. So let's see, what are we going to plug in the calculator? Well, we're going to have Normal Cdf. And now let's plug in what we know from the problem. Uppercase. Now here, lower. What's the lower bound? Well, let's look at our picture here. This is the region that we're interested on. What is the left side of the region that we're interested on? The left side of this region is 22, so that's our lower bound. So we know the lower bound is 22. Now here, the upper bound. The upper bound is going to be somewhere right here. We don't exactly know what it is, so we're going to choose a point that is pretty far away to the right from 22. I'm going to choose 1,000. Now the mean, we know from the problem that the mean is 20. And the standard deviation from the problem, we know the standard deviation is 5. Once we have that, use our calculator and we're pretty much done. So let's clear that. Let's see. This is what we have. So normal CDF, you can locate that by pressing second and distribution. It's right here, option number 2. So let's scroll down, option number 2. Then we're going to put 22, comma, 1,000, comma 20. If we see this, we're going to have 0.34. Percentage, so let's multiply that by 100. So we know that there is a probability of 34.40, let's down, 46%. So lastly, let's look at another example here. Let's say it says a height of a man. A survey was conducted to measure the height of a US man. In the survey, respondents were grouped by age. Excellent. In the 20 to 29 age group, the height were normally distributed. So that means normal distribution. So here it is, what we're interested on. We know that the mean is 69.2. And the standard deviation is 2.9. So standard deviation is 2.9. Standard deviation 2.9. Now, a study participant is randomly selected. Now, we want to find the probability that this height is between 66 and 72. So here, we're going to have values, which in this case, we have 66 and 72. All right, so before we start thinking about what we put on the calculator, let's just have a visual interpretation of what's going on here. So this is what we have so far. We know that the mean is right in the center. So we know that the mean is 69.2. So it's going to be somewhere around here. So this is 69.2. Excellent. So now we want to find the probability between 66 and 72. So if this is 69, I'm going to say 66 is around here. And I'm going to say that 72, it's around here. So the problem is asking us for this. Find the following area. We want to find this. We want to find the probability between those 2 points. So we want to find the area in that region. So can we still use our calculator? Yes, we can. So let's see. Let's write that down. So we're going to write down normal Cdf. Now here, notice that this is the area that we want. So this means that now your lower is the lowest point that you're interested on, which in this case, if this is the area that we're interested on, 66 will be your lower point or your lowest bound. And we're going to follow it by the upper bound, where again, if this is the area that I'm interested on, your upper bound is 72. Our mean, we can get it from the problem, 69.2. And our standard deviation, 29. We have everything. Now let's use our calculator now. Clear everything. Again, to find normal CDF, we're going to press second, distribution, go down to option 2. And in here, let's just plug in our values, 66, comma, 72, comma, 69.2, comma, and 2.9. So this is the probability, but again, we want that in percentage. So let's multiply that by 100. So that means that we have a 69.79% for the height of the person to be 66 and 72 inches. So now, here's your entrance ticket. In your own words, just describe the steps needed to find the probability over normal distribution using the calculator.